y hablarnos de las streaming APIs. Así que nada, que os dejo con él. Seguro que es muy chula la sesión.
Gracias, Alba. I'm not going to present in Spanish. Unfortunately, my Spanish is quite bad. But if you have questions in Spanish, I may be able to understand and give you an answer. So this is a talk I gave out at Australia DX about 3 weeks ago. And I've made it a bit longer for you today. And of course, I can adapt. I have a lot of knowledge on this particular topic. I've been playing with the streaming APIs for some time. I actually wrote a project on streaming APIs at platform events recently. So that is something I'm quite knowledgeable in. All right. So, of course, I'm working for Salesforce, so I have to give you the forward-looking statement. I cannot comment on anything that is going to be on the roadmap, although I will be talking about the roadmap. Don't buy any licenses based on that. Also, do not ask me about the Tableau acquisition. I'm not allowed to speak about that. I wish I could, but I'm not able to talk about that at all. All right. So my presentation is in 3 parts. First, I'll present you the 4 streaming APIs. I'll tell you a bit what they have in common and what is different between those types of streaming APIs. I'll share use cases as well. And then I'll talk about specifically what is new in latest release, Summer 19. And then I'll finish with a quick demo and some tooling to work with the streaming APIs. So first of all, does everybody know what are the 4 streaming APIs? I'm just curious. No? Any idea? Maybe just one, at least 4? No? 1? Okay, go ahead.
This is the normal streaming API with which you can subscribe to a topic.
Okay, so actually that's a good answer, but it's the naming changed a bit, and that's our fault actually. Salesforce wasn't very consistent in the way we named those streaming APIs. So at first the streaming API was this PushTopic, that's the exact name, but then it evolved a bit, and actually there's more than that. So it all started with generic and PushTopic, which are considered streaming APIs, but the truth is we have actually now 4 streaming APIs which fall under this like major label, and then specialized APIs under this. Now I'll explain a bit more what these have in common. They address different use cases, but they work basically on the same technology. Now, the first 2, generic and PushTopic, can be considered as legacy. They still work, but they've been around for already a couple of years, and we're not really investing in these technologies, these APIs. Now, the new ones, which are marked as current, again, it's just me saying that, it's not an official stance on this, are the platform events and change data capture. This is really where we work on and where we deliver new features. So I will talk a bit about the 4 at first, and then I will stop talking about the 2 legacy ones, and I'll focus more on platform events and change data capture. By the way, if you see in my slides, CDC, that is change data capture. I'm not writing the whole thing each time. All right, so what do they have in common? Actually, they all work with the same technology. It's all something that is coming from the open source world called CommentD. That's a technology that is used to publish, subscribe, and to build event-driven architecture. That's actually a push technology to send notifications to clients from the server. I'll give you more detail about the publish subscribe architecture next, but that's actually the main thing about this technology. It's about pushing information from the server to the client. The difference with a classic browser request, in which the browser page requests information from the server and the server answers, this technology is going the other way around. The server is pushing information to the client. I'll show you more with some schemas next. Another thing that is interesting about this technology is that it's actually very good for real-time applications. And so if you receive messages from these APIs, you have also a replay capability. You can look back at history, but there's actually no saving data here. So what is this good for? There are really 2 main types of use cases which are very interesting with the streaming APIs, whether we used one of the 4. The main one is actually for integrations. So if you have Salesforce platform and you want to integrate with another application, third-party application, you can use the streaming APIs to work with integration. You can detect data changes, for example, on the Salesforce platform, and push those changes outside of the Salesforce platform. And same thing, if you have a change on an external system, you can actually push notifications to Salesforce to tell it that you have updated your data. This is also very interesting because you can actually use these APIs to do broadcasts. So if a system among maybe 10 different system changes, you can use a streaming API to broadcast that change to a network of participants. And the advantage also is that this is actually happening in real time. So when you have applications which rely on real time, like for example, if you have a mobile application with I don't know, chat notifications, you could do that with a streaming API because it's real time. I will show you that, of course, during the demo. So how does the whole architecture work? So this is something quite typical of a publish subscriber model. This is not something invented by Salesforce, but these principles work also with other technologies. And the idea is that we have at the center of the solution something called the enterprise messaging bus. That's the software which takes care of delivering the messages. We have event producers, so the ones that are going to push events. And we have event consumers. Event consumers are the ones who are listening for the events. By the way, I'm talking about events or messages. These are the same things, just different words for it. So the way it works is that for each type of message, there is a channel. Consider a type of message like pretty much like an object. It's an object definition with maybe fields or no fields, but there is a specific name for this particular object. And so this corresponds to a channel. And there can be multiple channels on the messaging bus. Now, the way it works is that even consumers subscribe or register to a given channel. They're saying, I'm interested in this particular type of message. Tell me if there are any messages on the bus for this particular channel. And then when the event producer publishes a message, so creates kind of a new record of the message, it talks to the enterprise messaging bus. It doesn't know about the event consumers. And then the bus itself is responsible for broadcasting to all consumers. So what is very interesting with this architecture is that the producer does not have a direct access to consumers. And this is really interesting because it brings decoupling. That means that even consumers can come and go at any time. Doesn't matter to the producer. The producer only knows about the enterprise messaging bus. There is no tight coupling between producers and consumers. But there's a whole talk track about this. I'm not covering this today, but this is the idea behind event-driven architecture. You basically desolidarize different services because they don't know about each other. They just know about a bus that is central to the application. And so you don't have any links between the different services. They only link to the bus. Now, I mentioned these APIs have a lot of things in common, but they do have differences. That's the reason we created those 4 different APIs. Here, I'm going to list the major differences in terms of data structure, type of publication, and type of subscription. And you'll see what API fits which need. First, in terms of data structure, some of these APIs allow you to define the structure of the messages that are being sent. Others impose a specific structure. For example, if you take PushTopic, a PushTopic is actually defined by a SOAP query. So that's a SOAP query with different fields from a single object that you're querying for. Now, you don't have the choice to create extra fields. The fields are actually fields from the record. So you don't have the choice into the structure. For generic, it's a whole different story. You have actually a string which can contain whatever you want. The string can contain, for example, you could put XML there, you could put JSON. It's up to you. You have about, I think it's 2,000 characters of whatever you want. But it's limited in terms of size. And then there are platform events. So platform events are a big change in terms of a strategy for us because we started to create a structure. So it's more or less the same thing as generic, except this time we're doing validations. We have a different set of types and fields. And in the end, of course, everything gets transformed into JSON. You can see that the underlying technology is the same, except this time we are validating the type fields. So when you declare a platform event type, you're saying it has 3 fields. One field is a text string, another one is a date, and maybe another one is a Boolean or checkbox. You will check for that before publishing the actual event. And when you receive it, you can be sure that these types are actually the right types. Lastly, change data capture is pretty much like PushTopic. It's also defined by a target object, except this time there's no SOAP query. It's all the fields on that particular object, especially the ones that have changed and that have triggered the object, the change data capture event. Talking about that, let me go now into the publication part. So some of these messages can be published manually. Others are only published automatically. For example, PushTopic and change data capture only publish automatically. You cannot trigger them manually. The reason is that both of these types of messages rely on a change in terms of records. So the push topic is only fired when the result of the so-called query that defined it changes. So for example, if there's a new record or if a record was modified. And the last one for change data capture only happens when there is a change in the record. So whether a record has been updated, deleted, or created. And then for the other types, generic or platform events, it's a bit more flexible. For generic, actually, there's only one way to publish a generic event. It's by using a REST API. There's no SOAP, so it's only REST. And then for platform events, there's a lot of options, and I will get back to that because there's a whole range of options, whether it is from code or without code. You can use different techniques. I'll explain more in the next slides. Let me now go to subscriptions. Subscriptions, it's half-half. For the legacy ones, this was only possible with code. So PushTopic and generic can only be subscribed to with code. That's a lot of custom code, actually. And for platform events and change data capture, that's going to be declarative again or code. Now, starting from there, I'm going to focus more on the most recent type of APIs being platform events and change data capture. So forget about PushTopic and generic. I'm done talking about those. I'm going to focus on platform events and change data capture. Now, I'm going to go back to the publisher subscriber model that we had before. And I'm going to give you the different options in terms of publishers and subscribers for these different types of APIs. So at the core of the solution, we have the enterprise messaging bus. And then we can have publishers of two types. We can have Salesforce platform, or we can have also external apps. And same thing for actually the subscribers. These can be external apps, or it can be also the platform. You can very well stick to inside intra-platform messages, or you can also work with external messages only, for example, or you can mix and match. Now let me cover the different options we have. Now, if you are on the platform and you want to publish a platform event or a CDC event, change data capture event, you can use two things. You can use code, an Apex statement. There's something called eventbus.publish, which lets you publish the message. It's pretty much similar to creating a new record. You have the object in different fields, you can create it. Or you can use something like a bit more declarative. You can use a process builder or flow to create a new event. This is with clicks and no code. Now, if you are talking to an external app, or if you want also to use code on the platform, there are options. So you can use the different platform APIs. You can use the SOAP APIs, REST APIs, or even the bulk APIs if you have a lot of messages that you want to publish. So this is available whether you're on external apps or on the platform. That's for the publication side. Now, on the other side, if you want to subscribe to an event, two options. When you're within the platform, you can use code, and you can actually write the Apex trigger to receive those type of events. Or you can also write something like a process builder or a flow. So again, there's the same equivalent to the publication side mechanism. It's Apex on both sides, or even declarative solutions. Now, the part that changes a bit is for receiving messages on the external apps. Now, if you want to have a client which receives messages from the Salesforce platform or from the enterprise bus, you have to implement something called the buyer protocol. That's the technical name for the protocol that supports the push technology. And here I've just listed a couple of implementations of this protocol. We use by default the command implementation, which is the default implementation of this protocol. But it's an open standard, so that means multiple libraries can implement it. That's why I've listed also Socket.io and Fay, which are other options. This can work with any technology, by the way. So by default, Command was written in JavaScript, but it supports more than that. It supports with Java, it can be run with Python, it can be run with any kind of technology. Now, you could also use that buyer protocol within the platform, but there's actually a little trick here. If you want to receive events within the platform, and that is interesting, especially in the user interface side of things, you have something called the EMP API component or service that I want to highlight. Now, you could, and you had actually in the past, you had to work with a buyer protocol client in the past, but this wasn't working very well. So we have a solution to that. It's actually easier to use and more performance. That's the EMP API. By the way, EMP stands for Enterprise Messaging Platform. That's another way of calling the bus. Right. So let me talk more about the EMP API. So the EMP API is actually a wrapper around CommentD that we provide to you in order to communicate with the to receive actually streaming events. So this supports all the 4 streaming APIs, not just platform events of stream data capture, and also work with generic or PushTopic. And there are actually 2 versions of it, one for Lightning, an Aura version of it, and a Lightning Web Component version of it, which is brand new, by the way. This is part of the features introduced in summer 19. They do exactly the same thing. The naming is a bit different, but they have the same type of functionalities. Now, why don't we use a direct CommentD connection like we used to in the past? Well, there are a couple of reasons. First of all, the CommentD connection needs to be authenticated. So there is a token that you must retrieve to be able to receive events. And when you're already within the platform, it doesn't feel right to re-request an authentication token. So you can skip that altogether when you're using the EMP API. You're already within the platform, so no authentication needs to be done. Another reason, which is actually the most important one, is that we are sharing the connection across the entire page. When you have an Aura component or a Lightning Web component on a Lightning page, they actually are using the CommentD connection, and they use it for different purposes, whether it is your custom code or even internal purposes. You also have active connections going on the pages to detect notifications that are built in the project. So using that EMP API allows you to share the connection across all the components that are on a page, but you maybe cannot access those other components. And lastly, if you are using the CommentD connection, you would have to have a static resource with a specific client, so a specific version of CommentD, for example, and you would have to update it from time to time, or you would have to manage this. So this is gone. You don't have to do this. It's already wrapped around the EMP API, and we make sure that we update it if the EMP API version changes. And lastly, there's very little code you need to write. If you are working on CommentD, there's a lot more code you would have to write and to write to develop. So that's sorry, this is going to be much simpler to use. Now, let me show you really what I meant about sharing connections, because it's really the key idea behind this implementation. So, take for example, you have a Lightning page. This is running on your browser, and on the other end, you have the messaging bus, which is the one that delivers the messages. Now, on this page, you have your own custom components, but there are also components which are internal to the platform. For example, there's the little bell symbol like on top of the page, which gives you notifications, for example. And maybe you have also some pages which are using the Lightning Data Service to refresh automatically when there are some changes. All of that is using the enterprise messaging platform to refresh the page in real time. So instead of having a single connection between the CommentD server, which actually is monitoring the bus to capture the new events that are being published, well, we have the EMP API back there, which allows a grouping of all the connections before they go out to the CommentD server. This is what helps us not to have one connection per component. And this is really important in terms of performance. So that's the idea behind the EMP API. It hides the complexity and it regroups all the connections that are shared on a given page. So it's scaling and it's performant. Now, when you use the CommentD, whether you use the EMP API or whether you use a CommentD client, all the channels or message types have a given name. So depending on the type of event you're listening to, they have different ways of being named, and all of that is given the channel name. Here I've listed a recap of all the different types of events. We don't need to discuss this much, but the idea is that they have a different name, different prefix. So for example, when you push topic, it's /topic/ and then topic name. One thing that is interesting is that for platform events, it's __e after the name of the platform event. And for change data capture, it's __ change event. That's really interesting. I won't go much in detail on this, but that's just interesting to see, because after that, except for the channel name, the way you connect to the different APIs is really the same. Now, again, all these different types of API use CommentD, and so they work with a replay capability. If you publish a message, all the subscribers which are actually registered to the bus will receive the message. Now, if you haven't registered yet, you missed the message. What happens? Well, the message is actually saved for a very short time. It's never saved directly to a database, but there is something called a replay capability. each of the events or messages that are being published to the bus have something called a replay ID, and this replay ID keeps on incrementing, so 1, 2, 3, 4, 5. This is just the time. So the latest one is number 4. And what happens is that when you missed previous messages, there are different options to get new ones, the older ones. We are keeping messages for about 48 hours. So the ones that happened before that are gone forever, never saved, so you cannot replay them. And you can, when you lose some messages, you can actually ask to replay all the messages that have occurred in the past given this window by asking a replay ID of -2. This will give you all the last minutes in 24 hours. Or you can also ask for just the new ones. So -1 gives you all the ones that happen after now. If you know that you have received message maybe 3 and you didn't receive before that, you can actually resume the connection starting from message 3. Saying replay ID equals 3, and you will have all the ones occurring after number 3. Provided, of course, they're still in the retention window. So that's the way it works. The messaging bus needs to go very fast, and so that's the way we do it. We don't save data to the database. That's why this technology is working. Now, let me jump into what is new in summer 19. There are a few things that have changed. The first thing that I mentioned already in the previous slide is that we now have an equivalent to the Aura component called EMP API. This is an equivalent for EMP API in Lightning Web Component. Same kind of features. It's just that it's working better with the new syntax. And another thing that is good is that you don't have a tag to include in your markup. It's just a JavaScript library, so it's easier to use. Then 2 types of changes, some for platform events and some from change data capture. For platform events, there's something very new that's called the publish behavior. So I mentioned that the messages that are being sent are not actually saved to the database, but when you work in Apex, you're actually within a database transaction. So for example, let's say you have you're doing a lot of operations, and at some point an operation fails. When the operation fails, the database transaction is being rolled back. So your changes are being canceled and you get back to the starting point. But if in your code, in your Apex code, you actually publish a platform event, the platform event is gone. There's no way to roll back the platform event. With this new publish behavior, you can actually wait for the end of the Apex transaction to publish the platform event. So that means that if you don't get to the end, if your Apex code crashes before the end, you won't publish the platform event. It will wait for the end of the Apex execution to publish the platform event. By default, it's immediately right now, but you have the option to use after commit, which is a bit safer. But it's also something that you have to take into account because maybe all your Apex isn't done executing. So maybe you're still modifying records. And if you have something that reacts to the platform events, it may be receiving the platform events before you finish modifying your Apex code. Now, we have also introduced a few things in terms of error handling. One of those is the ability to resume batches of platform events. I mentioned that you can have Apex triggers to capture platform events. The problem is the volume and the limits in terms of how many events you can deal with are quite high compared to Apex limits in terms of, for example, CRUD operations. So you can have only 200 SOCO queries in a given Apex transaction. Now, for platform events, you can process up to 2,000 events. So if you have some operations to do, some SOCO queries to do, you can very much quickly hit the limits. With that, this is why we introduced resume checkpoint. If you hit the limits, you can actually continue with another resume checkpoint to process the other messages and resume the operation when it's a long operation. And lastly, we also introduced something new. When there is an error, when you publish a message, you don't get a confirmation actually. Because it's asynchronous, the publish operation, there's no waiting for a confirmation that you have actually published the message. So we introduced another mechanism to actually detect errors. Before that, it was not possible to detect errors. The new way to detect errors is actually something asynchronous. There's another platform event telling you about publication errors. So for example, if you publish 200 events, you expect those 200 events to go out. Maybe one will fail for whatever reason. Well, with that, there's actually a way to getting called back by another platform event about errors in the publication process. It's a bit meta because it's a platform event telling you about a platform event publish error, but that's the way it works. So this is better. This is the thing that is actually still kind of work in progress. All the other features are okay, ready to go. But the last thing about the publication error is still bad. Now, in terms of change data capture, there's something new here. We now have the ability to create triggers for change data capture events. Before that, triggers were only for platform events, but now we also support CDC events. So that's actually interesting because you can think about change data capture pretty similarly to actually a real Apex trigger. So what's the difference between a classical Apex trigger and a CDC trigger? Well, the difference is that the CDC event actually happens, again, outside of the transaction. So if you're on a classic Apex trigger, you're within the transaction. You can still modify data before it's saved to the database if you're trigger before. Now, with CDC, your data has already been published to the database. Then it has changed the transaction that modified the record is actually finished. So you can do something else outside of this transaction if you want to change data there. Finally, no, two other things. Last thing is actually group channels. So this is something interesting. I haven't played with that yet. Seems very promising. We can now group different channels together. So when you work with change data capture, you may be interested in changes of lead, contacts, accounts, etc. But you would have different events for each of these modifications. With CDC group, you can actually say, I'm interested in changes of all of these objects, and you can group them into a single channel. This is really interesting because it's actually helping a lot in terms of processing of these events. And also it's helping in terms of limits. You have fewer calls to these streaming APIs if you just use the group channels instead of seeing individual channels for each of these sub-objects. It would be very fun. And lastly, there are just a couple of new standard CDC events. I've written this down just to be exhaustive, but it's not really interesting. It's about campaigns and contracts, I think you got, but I don't have the full list. We have a pretty good coverage in terms of change data capture events. Most of the standard records types are actually covered.
For customer updates? For customer updates?
So for custom, you can declare whatever you want, and for standard object, they're just a limited set. But actually, it's growing. It's growing. The list is growing. Right now, let me get into the tooling. So, oops, yeah, after that. So to demonstrate a bit how this all works, I'm going to share a tool I built and actually published on the App Exchange that I call the Streaming Monitor. And the way it works is, as its name tells you, it's actually a tool that lets you monitor any type of streaming event. So the way it works is that it will scan your org for any type of message of event, that has been defined. In this particular demo org, let me start maybe with that. I have defined a platform event for purpose of test. Let me show you that. So I've defined a very simple platform event that I called demo event with just one field that is just a message. So it's just a text field. And of course, there are also some change data capture events. Let me activate them, by the way. I'm going to activate those. So these are all the standard CDC events that are available. They're not activated by default, so you can just activate them by using this interface. I'm going to activate one for, let's say, case, which is very simple to do. So I've activated case, change data capture. Let me save that. And we're going to start sending events, if it will. Yeah. All right, I'll leave that open. Now let me get back to the monitor. So the monitor allows you to receive events, and in certain conditions to also replay and publish events. So by default, the most convenient feature is actually this thing, subscribe to all. It will actually look for all type of streaming API events that are defined on the platform. So if I do that, if I click on subscribe to all, it will subscribe. The CDC event isn't defined yet, but it will subscribe to my platform event, and you can see here the channel of my demo event here. Actually, it's just hidden under the click folder. Just get rid of that. Yeah. So that's the channel name /event/demo event. That's the name of the event that I've defined. So now that I'm subscribed to it, I can actually publish it from here. So I'm going to say it's a platform event. I'm going to select my event name. It's demo event. This gives me the streaming channel. This is also useful for publishing. And then I can actually write the message body. So that's actually message. Oops, extra S here. Oops. Underscore C, just like a custom field. And then hello. If I publish here, I've received it, and you can see the messages is incoming here with all the payload. So my custom field here and some extra data. Now, this is interesting as is, but it's even more powerful because you can also leverage the replay capability. So if I refresh this page and I start again from scratch, if I want to get back previous messages, I can also replay all past events and subscribe to all. This will roll back in history and you will see previous events. So there's the one I just wrote right now. That's this one. That's the one I just said, hello Granada. But there's also another one which I created yesterday to prepare for the talk, just test. So this is very convenient because if you don't have this kind of tooling, there's no user interface to receive the events by default. So that's something that lets you save a lot of time. I see that my case change data capture event was saved, so I should be able to subscribe to it normally. So I'm going to select it here, case change events. All right, so now I subscribe also to a change data capture event for case. Now, let me actually show you. I'm going to open a new tab here, and I'm going to actually create a new case on another tab, and you'll see the notification coming up there. All right, that should be just enough. So if I save this, I'm creating a case, and you can see the change data capture event that just got triggered on the other screen. Now, if I go back into the detail about this particular event, you can see there's information about the object that was created. It's pretty empty right now because I didn't enter anything, but you can see the different field names if needed. And it's also very interesting if you modify the object. So that's the little tooling I built, and that's also a great way to see the platform events and change data capture in action. But you can also play with the other types of events if you want to subscribe or publish the other type of events. There's this little tool here which lets you publish the different types of events, the ones that can be published with code. And if you want to register also the different source of events, if you want to create a new, for example, new platform event, there's a quick links for the registration pages. Change data capture, etc., or generic also. Even the query, which lets you create PushTopic if for some reason you want to create a PushTopic. That's the only way to create one. There's no user interface. You have to run this Apex code to create a PushTopic event. Anyway, so that's it for the little demo here. Going back to the slides to conclude. So we saw the 4 different streaming APIs, and I've given you some points about use cases. I think the most interesting one is integration. So when you have different technologies that want to communicate with the Salesforce platform, and maybe they are on different languages, maybe they have C#, Java, or even JavaScript. They all work together with platform events because there are libraries to communicate with the messaging bus in any language. So that's very convenient for integration. It can be a way to replace Salesforce Connect. For example, if you don't have the money to buy an add-on and to provision a license for Salesforce Connect, you can actually create your own sync mechanism for an external database by using a platform event system or change data capture system. That's the way to do it. Then real-time apps. So real-time apps are a bit more tricky because, of course, there are some limits. So you have to be very careful about the volume of data you would transfer to a number of subscribers. There are some limits for everything we do. And lastly, I showed you the different options to publish and subscribe to platform events and change data capture with or without code. Forget about streaming API, the PushTopic or generic. Better focus on those two things here. Now, before I finish, learning material. Two things. Trailhead is great because there are a lot of content for these platform events and change data capture events. The two ones on top are actually models, so more theoretical content. And the last one is the one I wrote for 2 TDX ago about platform events. but it's been updated, and you can actually see the EMP API in action if you want to create an application. It's giving you the basically a little chat application which gives you notification with the EMP API. It's overall so far it hasn't been updated with Lightning Component, but it could be achieved also with Lightning Component as well. And lastly, the streaming monitor, if you want to grab it from the App Exchange. The code also is open source, so I've published the code on GitHub. If you want to take a look at it, feel free. And that's about it. I'm going to open for questions if you have any. Thanks.
Questions?
I have one.
Yeah, sure.
So if you have one publisher and many subscribers, if you publish one message and one subscriber receive it, the other subscribers will receive the message, or only one?
It's broadcast. All subscribers, or maybe no subscribers, because you don't know actually when you're publishing if someone is listening or not.
Okay. And is any built-in way to know for a given subscriber if any other subscriber has already received this? Built in the event bus isn't.
There's no acknowledgement system, no. You could implement it by having callbacks. For example, you could call a REST API and say, hey, I just received a message, or maybe send another event, but then it's in this loop. There is no acknowledgement system. That's the reason actually why this system goes very fast. It's not waiting for anything, it's just pushing a lot of data. This is really meant for high volume processing.
So, because can you remove a message?
Once it's published, no. The only time where it goes away is when the retention windows clears it, so 48 hours.
Because I'm thinking about receiving a message, and once I process that, I could do another request to the Salesforce or to remove the message. So
no, there's no delete operation, there's no update operation, it's just create, and that's it.
You can know how many subscribers you have within the platform. The battle cell platform. Don't know that.
Yeah, there's no API to do that. Yes. Normally on the comedy there would be APIs to do that, but we're not exposing this.
CDC triggers those have the same restriction as Apex triggers, or for example, can you make a callout from a CDC trigger?
You can modify things because you're outside of the transaction, so it's really a new transaction, so the limits are reset basically from the previous call. I haven't played much with those yet, so I'm going to give you the theory and then that's going to be practice.
Where are you defining those?
Oh, just like the normal trigger in Apex. And the only thing that changes is the name of the object. You have this underscore change event, and you can just write a trigger for this underscore change event. So account underscore change event. You have triggers, CDC trigger for change for accounts. And that can work on top of the actual Apex trigger that you have written for accounts.
And you have the after update, after delete, or after.
So not for CDC. So.
No.
Because you're outside the transaction, so there's no before or after. It's actually just happening once.
Okay. But can you distinguish between an update and delete?
Yeah.
Yes, you can. Yeah. All the operations, the delete, etc.
CDC trigger is just after it.
So first the event is published, and then the trigger fires.
So if you're talking about change data capture, the first thing is that trigger actually is happening because the Apex transaction finished, and then the publication of the event happens.
And the CDC trigger after this.
You can just stop the publishing the message from the CDC trigger.
So no, the message is already published. Okay. So, because it's not a transaction, there's no rollback. It's the same problem.
I mean, I don't know. You just maybe you need to do some.
You could ignore it, but that's up to your code. You cannot cancel it. So the danger is that if there are other subscribers, the other subscribers will be getting it. So maybe they're going to do some processing.
So you cannot do the same that with the platform events, that you can set up the platform event to run after the transaction ends.
No, not for CDC. No. The thing is, the major difference is that you're not triggering change data capture with code directly.
No, it's yeah.
I don't think there will be an after commit because it's not. It's necessarily after the commit.
After the commit, yeah. Right.
Are you using these streaming APIs to do this connection between, for example, Salesforce and Heroku with the external object?
Yes. So if you for external objects, you mean for Salesforce Connect?
Or for example, yeah.
No, it's
communicate different system with the objects itself.
It's a different technology. I don't think it's being used. The Salesforce Connect existed prior to the use of streaming API.
Another question. I saw in one of your schema that there is a flow in which you can use the streaming APIs to connect to different external systems.
Yep.
Is there any reason for instead of doing that, use another message broker like Kafka or RabbitMQ?
You could do that actually. Sorry. Now, Kafka is another messaging bus, and actually the truth is we are using Kafka behind the scene. So that's the technology that supports the enterprise messaging bus. I didn't write this because you actually don't have any interface to directly communicate with the Kafka bus, but that is actually what's happening. And to give you even more detail, there were two technologies we used to support streaming APIs. First, it was actually our own database, but we were not allowed to do all the CRUD operations. But that didn't really scale. And then we introduced high volume. You can see that when you're creating platform events, the first one were standard volume, and then there were high volume events. And high volume events are actually using a new infrastructure. That's the default now. It's using Kafka. Sorry.
So you're mentioning high volume. How high is that? I mean, could we potentially use these for
hundreds of thousands, millions?
IoT example?
Yes. The only problem is not the number of events you publish, it's more the number of subscribers that are active at a given point in time. And that's depending on your license. And yeah.
So what are the limits that we should watch out for here?
Number of active subscribers that are concurrent for a given message. That's the one you can reach very easily when you have, for example, an IoT fleet that is listening to a lot of messages. If you have a lot of publishers, it's not so much of a problem. The problem is number of receivers. Sorry.
So for instance, duplicate the publisher. I mean, the publisher is really the same.
But the publisher is not actively registered. It's only fires the message and then it's gone. So,
but I mean, if the problem is in the number of subscribers you have for an event, you can have two events pretty much the same, and then have like two channels.
So no, the number of subscribers is actually across all channels.
All right.
So no, it doesn't work.
But you still work. I'm not really familiar with these technologies in Salesforce, but in other systems like Google, WhatsApp.
Yeah.
And do you work with topics and messages? Things are like isolated channels.
Yes.
Is that the same concept?
Oh, it's the same concept. I mean, we didn't invent this. It's really a reuse of terms that are any technology called the enterprise messaging bus. There are loads of different systems that do that. Some of them are not streaming. I mean, some of them are just buses on which you have to consume manually, and then the message is removed from the queue. Some of high volume like Kafka, when there's no confirmation or no acknowledgement of messages. But yes, the theory is the same for all.
You said that you're not storing any data about the messages, so that's why we have this window of 24, 48 hours. Where is this data allocated during this time?
So it's on the Kafka bus actually.
On the Kafka.
Yeah, and there's a rolling data that just gets on being erased and rolls.
So if this, I mean, I guess that this Kafka server will have like if a server is going down, you will have like replicate this information in another instance.
There's going to be
can be lost.
There is replication on our data centers, so I suppose I'm going to say that.
It shouldn't be lost. No?
Yeah.
So both the __e and the _change event both are deleted after.
Yes. Any kind of streaming API, whether it is PushTopic, generic platform events, or change like capture, whatever streaming API you're talking about, they only have this 48 hours retention window.
And in terms of deciding which one you're supposed to use when you want to do something, what is the major?
Well,
if you need to do something with them independently, we all need to know that it's publishing and subscribing. What is the point of?
I think this is the best thing you can use to decide whether you're going to use code or not. And I mean, frankly, it's between those two things. You can't forget about the other ones because they don't do more, they actually do less than these two new things. So do you want to fire your events manually? Is it something you want to control? Or is it something that just actually is a reaction to a change of a record? It's as simple as that decision. If it's a record being changed, then it's a change data capture event, or it could be also a platform event, but the easiest way is actually a change data capture. And if you want to publish it manually, then it's a platform event. Now, if you also want to add custom data, then it needs to be a platform event. It cannot be a change data capture event because the change data capture data is only tied to the object, the record that is being changed. So if you want to add custom fields or anything, well, it's platform event. Really.
previously you have said that you're using these streaming APIs internally for your Lightning components. Could you tell us a few cases of this?
So there's when you have, for example, on a record page, different components. I don't know which record page actually uses that, but when you have multiple components on a page, and some of these components, like details use, are getting updated seamlessly, they're actually using the EMP API to do that.
Yeah, but you're speaking about communication between components or within the server?
So this is within the page actually, but the page has the EMP API, and there's also the server pushing the changes. So it's actually all of that. There's the EMP API, which sits basically on top of the page and actually is broadcasting to subcomponents the changes that are being sent by the server itself. So if you have another user that is modifying a page you're looking at, there's a chance that it will refresh according to that change. And same thing about, actually it's hidden right here, but I've disabled it also, but there's normally on top of the screen there's a little bell icon with notification. This is also using the streaming APIs. In that particular instance, I disabled it because, I don't know, I don't remember why I disabled it, I disabled it. Okay. That's also using the streaming APIs.
What about libraries in other languages to subscribe to capture events or things that are captured?
Yeah.
Because I've used one that was an EMP connector with Java.
That's a very old thing.
Yeah, it was
Yes.
kind of unofficial.
So it was created by a Salesforce employee, never was maintained, and it's really unofficial, and it doesn't really support all the use cases. I think it was only created for the first type of API, so streaming and push, the generic and PushTopic. Sorry, so I would discourage you from using that. You can, if you're using Java, you can use the command D implementation because that's the standard one. So you're sure it will work. You just have to take care of the authentication yourself. The advantage of the EMP connector was that it was already wrapping the authentication to Salesforce, but it's not so complicated. And then just to give you an idea, let me see. I don't know if I have this. I can show you that for one of my demos, I actually built something using the, So I actually wrote a demo for TriDX, and actually I used that also for Greenpost, but we had a whole demo around the use of platform events, and we had different systems, different UI. So we had a mobile application, we had a desktop application, and we had different devices operating robots in this instance with different programming stacks. So we had JavaScript, Python, C#, and all of those were using Command D client because they're all communicating with platform events. So you have Command D clients for any kind of language, basically. So that's actually very useful for integration. That's a very good thing. And we were also at this particular demo using it for real time because we had graphical component which was being updated as events were getting passed on. That's I could talk for a whole session about this demo, but yeah, the idea is that it works great for real time and for integration because multiple clients exist with different stacks. Oops.
How much of this could we reuse if the customer has already got a messaging bus? If they say, hey, I've got mine already, so I want you to integrate. Should we use same layer on top and then connect to their messaging bus?
So if the customer already has a bus, the problem is more the subscribing part on SaaS platform.
Mm-hmm.
I'd say it's easy to publish because you can just call REST API to publish a message. But to subscribe, you're missing the declarative part of things, I think, because that's a real advantage of platform events and change that I capture. That's the fact that you can actually write those with just process building. You can have a process that starts upon receiving a platform event. I think that's a really good added value. If you don't have that, if you have a solution that works with code, then it requires a developer to work with. So, and to reuse that, yeah, you would have to create probably some sort of replication to receive the event. I don't know how you would do it. Or you would have your bus call SaaS platform. That's not really the way buses work normally. They're not supposed to know to call someone. So you can actually do that with MuleSoft. That's another option. But again, that's not a license, so it's a Mule. It's free and answer.
Okay. What are the limits that apply to publishing, platform names, or
They're quite high. You will have to look at documentation.
something to do with licensing, single licenses.
Yes. But the number of messages that you can publish is actually super high. I think it's more than 10,000 per day. But it also depends on the number of.
Is there a limit per day, per hour, or there are
24 hours actually. But again, everything can be negotiated, I guess. So just have to know the special person with the permission and that. More questions?
Have a question.
Sure.
You said that there is a limit the subscribers number.
Yeah, that's also limited. I don't know the limit by heart, but it's number of concurrent receivers, yes, subscribers, yes.
So, as you said, that this system doesn't have an acknowledge system itself. So there could be that there could be like a subscriber leakage where I forget to detach.
Yes, it happened to me in the past to do exactly this thing, and that's actually why we kind of prevented people from using direct commit connection within the platform. That's why we use the EMP API, because actually it knows when you close the page or when you refresh the page, it must kill the connection or refresh a new one. But if you're using an external app, there's a risk that you forget to close the connection. It will time out at some point, but if you have something that cycles very rapidly, you can actually have dead connections, and yeah. And in that case, what will happen technically is that when you subscribe to the platform, to the EMP bus, you'll get an error because you have hit the limits. But this can also impact the other clients. So it's going to be very hard to find out which are the dead connections because you don't have a list of connections available. That's a risk.
You have a number.
You have a number, but you don't have a name. They're not named. The clients are not named. So that's the trick to figure out which app is actually causing the leakages, especially if you have a lot of clients.
Then they just reboot safe.
Just one thing before to go in with the giveaways, because we have some teaser now to give away. Guys, the next meetup will be in July. I think maybe we will move the date. I don't know, but most probably in July, and it's gonna be the global gathering for the GX. But after that, we have no more meetups planned. So I want to encourage you to come on to prepare a session, to prepare a talk, and to contribute with the community. You don't need to be a super expert in something. Okay, just if you think that something is interesting and you want to share this, or if you have faced a situation at your daily work and you want no one else to face this situation as well, prepare a quick talk and contact Paula or myself, and we'll be so happy to prepare the meetup, right?
And actually, I have a suggestion. If you want to talk about something new, there's the Lightning Component open source. I think that could be an interesting topic.
Thank you very much, David.
Pleasure.
I think really nice talk. And thank you guys for joining us.
Yeah.
And if you have extra questions, yeah, I'm here. So don't